All right, welcome back. Today we're going to put on our cloud architect hats to tackle a massive challenge. We're talking about taking an application on GKE and scaling it securely all the way across the entire globe. This, my friends, is where the real fun with networking begins.
Okay, let's just dive right in. Picture this. Your app is a huge hit. Users are popping up everywhere from Tokyo to Toronto. That's fantastic, right? But here's the question that really keeps architects up at night. Is your network actually ready for that kind of prime time? Let's find out. You know, to make this real, we're not just going to talk theory. Nope. We're going to design the network for a fictional SaaS company we'll call Global App. Think of this as a live architectural session. By the end, we're going to have a complete blueprint for global success. First things first, every great architecture starts with a really clear mission. So let's set the stage and define exactly what our global app needs to accomplish. This is how we translate the business goals into actual technical requirements. We have to serve users all over the world, so low latency is absolutely non-negotiable. We've got to scale on demand. Security has to be totally ironclad. And, this is a big one, our microservices need to talk to each other privately and super efficiently. These 5 points are going to be our North Star for every single decision we make from here. Okay, mission is clear. Let's tackle the very first piece of the puzzle, opening the front door. How do we let our users in from all over the world, but, do it in a smart, secure, and really scalable way?
It sounds so simple, but this is such a foundational question. How do we expose our services running deep inside our GKE cluster to the public internet? Now, there are a few ways to pull this off, but for a global application, we need a solution that is just as global as we are.
And our number one tool for this job is going to be Ingress for GKE. Now, you probably know the basics, but let's just get on the same page. Ingress is a Kubernetes object that basically acts as the traffic cop for all external access. It's not just about letting traffic in, it's about managing it intelligently, providing load balancing, handling all your SSL certs, and routing requests based on the URL. It is incredibly powerful. And here is the real game changer. When we use GKE's native Ingress controller, it automatically provisions a Google Cloud Global HTTPS load balancer for us. And what that gets us is a single global IP address that serves our traffic from Google's edge locations all around the world.
So let's trace a request real quick. A user types in globalapp.com. That request first hits Google's global load balancer, right at the network edge, super close to that user. From there, the load balancer, which is configured by our Ingress object, knows exactly where to send that traffic. It forwards it to the correct Kubernetes service inside our cluster. It's a brilliant way to get both global reach and intelligent routing with just one simple manifest file.
Okay, so the front door is open and it's secure. But what about everything that's happening inside the house? Our app is made up of all these microservices that need to chat with each other. So let's build the internal walls that keep that communication private. It is so critical to understand the difference here. External traffic, that's from our users on the public internet, that's what Ingress handles. Internal traffic is a whole different beast. This is our payment service talking to our user service. It should never, ever touch the public internet. It needs to be private, fast, and totally secure. This quote just sums it up perfectly. The core principle of a secure microservices architecture is to create this secure internal network, and then expose only the absolute bare minimum to the outside world. So, how do we do that in GKE? Well, the answer is another type of load balancer, the internal load balancer. By creating a Kubernetes service of type load balancer and just adding a simple little annotation, GKE provisions a private load balancer for you, right inside your VPC. This gives all your services a stable internal IP address to communicate with each other, completely walled off from the internet. It's fast, it's secure, and it is the right way to build those internal walls. Fantastic! So our single cluster is secure inside and out. But Global App is, well, it's global. We need to expand our footprint. We've got to deploy our application in multiple regions to get closer to our users. And this introduces a whole new level of complexity.
The call is actually pretty simple, and it all comes down to this number, 1. From the user's point of view, no matter where they are in the world, it should feel like one single, seamless application. They shouldn't know or care if they're hitting a cluster in Europe or one in Asia. They just want a fast, reliable experience.
Now, managing all this gets advanced really quickly, but let's just look at the two main strategies. First, you've got multi-cluster ingress.
Think of this like our global load balancer, but on steroids. It's a single ingress that's aware of multiple GKE clusters and can intelligently route users to the closest, healthiest one. Then, the second approach is using a service mesh, like Istio. This creates this whole dedicated infrastructure layer on top of your clusters to control traffic flow, security, and observability in a really granular way, even across regions. Both are super powerful options for true global service delivery.
All right. Our app is now global. It's handling more users, more data. It is time to upgrade our security to the maximum level. It's time to build a fortress by locking the vaults.
And that fortress is called a private GKE cluster. So what does this mean? It's a GKE cluster where your nodes have 0 public IP addresses. And even more important, the Kubernetes control plane, the master endpoint itself, is also not exposed to the public internet. This drastically reduces your attack surface. It is the gold standard for security.
But wait a second. This creates a new problem, doesn't it? If we can't access the master endpoint from the internet, how on earth do our engineers or our CI/CD systems run kubectl to manage the cluster? It's a great question. And thankfully, there are some well-defined, very secure paths to get in. The first one is Cloud VPN. It creates a secure tunnel from your on-prem network straight into your Google Cloud VPC. For higher bandwidth, there's Cloud Interconnect, which is a dedicated physical connection. And finally, a really common pattern is the Bastion host, a single hardened machine inside the VPC that you connect to first, and from there you can jump to manage your private cluster.
Okay, we've gone from a single application to a global, highly secure deployment. Let's just take a step back for a second and look at the final blueprint we've designed.
So here it is, the complete global app blueprint. For all our external traffic, we have a global load balancer that's managed by Ingress. Internally, we're using internal load balancers for that secure microservice communication. To scale, we have a multi-cluster strategy to give us that global reach. For protection, the clusters themselves are private, and for access, we have a defined, secure path for our administrators. See how every decision we made just builds on the last one? It creates this cohesive, secure whole.
And there you have it. In just a few minutes, we've walked through all the key decisions to architect a robust, secure, and truly global network on GKE. We've solved for external traffic, internal traffic, global expansion, and top-tier security.
Just remember, these are not just abstract concepts. They are seriously powerful tools in your architectural toolbox. We've laid out the entire blueprint for Global App, so the only question left is, what are you going to build with it?